Good morning. So today we're going to be talking about geometric shapes in math. And specifically, we're going to be looking at why certain shapes, what the qualities of certain shapes are. And I wanted to start with a little activity. So I want you to look at these pictures and I want you to think a little bit about what they all have in common. So we have some butterflies, picture of the CN Tower. It's a building in downtown Toronto, I believe. This is the Taj Mahal, this adorable puppy, this flower. What do they all have in common? So think about that for a bit. What you probably realized with all of these shapes, with the building, the dog, the flower, the butterflies, the Canadian flag, they all have one half of the building or of the picture that is the same as the other half. So even this dog's face, even though it was made naturally, obviously, he's very much the same on this side as he is on this side. He's got a little bit lighter coloring here, but for the most part, his face is sort of the same. His ears are sort of positioned the same. Same with the Taj Mahal. This is a beautiful picture because even the water is uh, sort of the same on one side as it is on the other. So we call this effect, the idea where one half of a picture is the same as the other half of a picture, we call this symmetry. And in geometry, we refer to it as lines of symmetry. Lines of symmetry. This means that one side of the image is the same as the other side of the image. Some images have no lines of symmetry, while others have more than one. So let me explain that a little bit more by looking at these. Again, so if I was to divide this butterfly, we could divide it in half. The CN Tower could divide it in half. This building, butterfly, the dog, the flower. But I want you to think a little bit about this picture. Why is this picture so appealing? Why is it such a great picture? I believe this is, I'm not sure if this is in Canada, but you'll see, even though it's not perfectly symmetrical, in other words, it's not perfect lines of symmetry on both sides. There's mountains, but they're different. The water is a reflection of the mountains here. There's a beautiful reflection on the lake here, but it's not exactly the same. But the picture itself is so appealing because it gives the illusion of symmetry, right? It seems like this half is the same as this half, and it seems like the bottom half is the same as the top half. It has two lines of symmetry, one down here because this side looks like this side, and one across here because the reflection in the water is the same as what's happening above the water. So that's two lines of symmetry. And for some reason, and I'm not 100% sure, but if for some reason, human eyes really are attracted to lines of symmetry, things that are orderly, the same on both sides. We really like that. It's a real symbol of beauty, of like complex shapes. If they have symmetry, our eyes are attracted to them. And I don't know if that's because our faces are, for the most part, symmetrical. I mean, it would be very strange if your faces weren't symmetrical and your nose was on one side of your face or your eye was like 2 inches lower than the other. That would just be weird. So we see that our bodies are very symmetrical. Our balance is based on symmetry. And so that's an important quality for humans, is what we grow up thinking about. And even animals, insects, everything in nature is very symmetrical. I want you to take a look at these flags. So these are the flags from around the world, right? So these flags from around the world, and it's amazing how consistently countries choose flags that have symmetrical images, right? So Denmark, right, for example, Denmark's flag here, I'm just going to get a line going here. So in Denmark's flag, we have a very symmetrical this way. This top half is the same as the bottom half. I couldn't divide it down the middle because this would not be the same on this side. India's flag, right, has two lines of symmetry, one going this way, you can fold it that way, and one going this way. So everything on this side is the same as everything on this side, and everything on the top, well, actually, that's not true because it's got different colors. So I can't, I lied. This line, I got to get rid of that line. Where is it? There we go. I get rid of that line. So that has the one line of symmetry down the middle. Argentina is the same, right? It's got the one line down the middle there. So Argentina. Go this way. In fact, Argentina does have two lines of symmetry. Germany, right? Line of symmetry here. Now, Brazil, a lot of countries you'll see this. The background of the flag will be very symmetrical, and then they'll have a symbol in the middle that isn't necessarily symmetrical, but the background frames the symbol in the middle. So the Argentinian flag is symmetrical in that it has that the diamond in the middle, which is totally symmetrical, but the circle thing in the middle is not. Jamaican flag. I don't know why I love the Jamaican flag so much, but there's something about it that just appeals to me. It has two lines of symmetry and fold it this way or this way. Israel's flag is the same deal. You can fold it this way and you can fold it this way. It's the same on both sides. France has one line of symmetry going this way. Austria, because the colors are the same on the top and the bottom, we have two lines of symmetry. Belgium's flag, one line of symmetry this way. Croatia is this way. It can't go this way because the top of the symbol in the middle is different than the bottom, but it has that crest in the middle, so it's got that line of symmetry. Lebanon has the tree in the middle, similar to Brazil. The tree is not symmetrical, but the rest of the flag is, right? So I could fold the flag this way or this way, and then the tree is fairly symmetrical, but it's a little bit different. Cuba flag, right? It can go this way. Finland's flag, similar to Denmark, line of symmetry this way. Ghana's flag's the same. Sorry, not this way. This way. It's the same. It's got that symbol in the middle. Ethiopian flag can go. Oops, no, it cannot because the star is different. This way. Egypt's flag is similar in that it's got the symbol in the middle. That is not completely symmetrical, but it's pretty close. But it's got that one line of symmetry. Iran's the same this way. And Syria, right, has got the horizontal line of symmetry. Actually, no, it doesn't because it's two different colors. It's got the vertical line of symmetry. So that horizontal one's got to come out. Slovakia, right, has got the one down the middle. And Macedonia has got this one and this one. Right. So you'll see that the flags of the world are designed. I mean, this is obviously just a few flags. There's a lot more. It's like 206 countries or something, or 197 countries in the world. So they all have different flags. But a lot of flags around the world are based on lines of symmetry. That we like the idea of patterns being reflected, being the same on one side as the other. And the Canadian flag's no exception. The Canadian flag has the one line of symmetry down the middle. So we tend to be attracted to that idea of symmetry, right? That shapes should be the same on one side as they are on the other. So geometric shapes also have lines of symmetry. So here's some of the common, I mean, the heart, I just put that in, but these are some of the common geometric shapes. So we have a triangle. You might know that this is called an isosceles triangle, which means that this side is the same as this side in length. This is like half an oval. We have a hexagon here, we have an oval here, and we have a trapezoid here. So if I was going to look at the lines of symmetry of these shapes, right, the heart can fold, which that's the best way of knowing if it has a line of symmetry. Can you fold the shape in half so it folds on itself? So I could fold this heart and it would land on the other half. Same with the oval. I could fold the oval, right? And this half oval, of course, the triangle can be folded right down the middle, and the trapezoid can be folded here. Now, don't think that you can fold the trapezoid here. I've had people make that mistake before. They think that because it sort of looks like a rectangle, it's going to be able to be folded twice. It's got two lines of symmetry, but it does not. You can't take this bottom half and fold it on top of the top half because these little end guys here will stick out. All right, so it does not have that. This line here should not be here. We'll get rid of that. Let's get rid of this little guy. And then the hexagon's a little tricky because not only can you fold it from point to point like that, but you can also fold it through the sides, right? If I go to the middle of this side to the middle of this side, I can also fold this half on top of this half. So it actually has tons of lines of symmetry. So I'll show you what it looks like. If I was to draw in all the places I could fold that hexagon so it landed on itself, it actually looks like this. Lots of lines of symmetry, right? So That's just a quick introduction to lines of symmetry. What I want you to do as a little exercise is a very quick 10 questions on mathletics. And it basically just takes you through geometric shapes and how many lines of symmetry each has. And so it's going to show you a couple of shapes. It might show you a triangle, and it might show you a square. And then we'll say something like, which one of these shapes has 4 lines of symmetry? And you need to be able to say, oh, this one has 4 lines of symmetry, and select which one. All right, so that's an easy one. I'm going to assign it this morning. And that is the end of that math lesson. Enjoy the rest of your weekend. It looks like it's going to be a beauty one out there. I hope you can get outside and throw the ball around or something, have some fun, and we'll talk to you next week.